Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin.
And in studio with us we have Isabella. And Isabella, if somebody wanted to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357, toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Wonderfully done right there. Now, why don't you let everybody know where you go to school and what grade you're in?
I go to school at Buena Vista and I'm in 5th grade.
Have you been a Bulldog for a long time?
Yes.
How long?
6 years, I believe.
So since kindergarten?
Yeah.
The only school you've ever gone to?
Yes.
So you're comfortable with it?
Yeah.
Let's see how comfortable you are with it. If you could change one thing about your school, what would it be?
Probably more trash cans.
More trash cans?
Ooh. Yeah.
Why is that? I mean, are they just not around a lot, or they're always full, or?
They're always full, and then sometimes people don't use them in the right places.
Well, good. You know what? That's an excellent suggestion, and I'm sure that your principal would appreciate that.
Yeah.
So you may want to tell Mr. Hansford that, hey, let's get some more trash cans out here, huh?
Yeah.
All right. How's math going?
Pretty good.
Now, you're working on some long division. That's pretty new for you?
No, but it's just not, I'm not comfortable with it. Yeah.
So not as comfortable as you are with the school, huh?
Yeah.
All right, well, let's go over to the board real quick. You and Devin will work on one quickly. So we have 2,659 divided by 28. Now, in your booklet, it says to estimate it first, then solve the problem.
So when we're estimating, we want to work with friendly numbers that are close to the numbers we have, so we know kind of what our answer should be close to. So when we're looking at 2,659 and 28, what are some friendly sets of numbers that we could work with?
2,500.
Okay, so we're looking at bringing this down to kind of the midway range. 2,500 divided by
25.
Now that's a really interesting friendly set of numbers here, because what can you do with 2,525 very quickly?
You can just divide them and then you get 100.
Yeah, you know that because you have the 25s here, that divides out and you have the 2 zeros left over. So you know that that's going to be 100. Is there another set of numbers that are closer that you could do the same thing with?
Yes.
Okay.
27,000.
27,000?
Yes.
So 3 zeros? Seems like it'd be kind of big.
2,700.
Oh, 2,700. Okay. Tools of precision, language. Okay, what can we divide 2,700 by?
27.
27, and we end up doing the same thing. In fact, these numbers end up closer than these numbers, than the 25s are, but we still end up with the same situation where you divide those units and you still end up with 1 and the 2 zeros. So even if we do a closer estimate to these values, we still end up close to 100, which is good information. That means we know when we actually divide this out, we should get something close to 100. So we're going to say that right now, this is about 100. Now, you mentioned that long division still provides a little bit of a problem or a challenge for you.
Yes.
Now, we don't have any trash cans for you to put long division in, but I know, much like you're familiar with, one of the issues with long division is it takes up a lot of space, right? Sometimes you don't have enough paper to figure that out. You got to just keep going downwards and onwards. A few weeks ago on the show, we were at Fremont Elementary School, and a young lady named Victoria ended up showing us this model for long division where you didn't have to work downwards. and we named it after her, and she wasn't quite okay with that. We did it anyway. So I want to kind of walk you through how this might help you with this. So we're dividing. Now, how would we set this up with a long division bracket? So we have our long division bars here. We have 2,659. Where could we put that?
Inside the box.
Now you say box, and I'm glad you did because that's going to come in very handy soon. And what are we going to divide this by? 28. Where does that go?
On the outside.
Great. Now, here's what I want to do. Instead of looking at this as a large number, I want to see if we can box this up into smaller sections like this. Now, we can start working in the same direction. We're trying to figure out how many groups of 28 can fit into each of these boxes.
Yes.
Now, how many 28s can we fit into 2?
None.
None. I'm just going to go ahead and put a 0 down right there. I have 28 times 0, and that's going to be 0. Now, I have 2 left. Instead of working down, this is what Victoria did. She brought it next to the number up here. So now we have 26. Right there. We didn't have to bring it downwards. We brought this over to the next place value over.
Yes.
So how many groups of 28 can fit into 26?
Still none.
Still 0. Same issue. Going to subtract 0. We have 26. We're going to bring this up into our next place value. Now this is going to require a little bit of side work here. How many groups of 28 do you think we can squeeze into 265?
12?
Ooh, 12 would be big, right? In fact, we know it's probably going to be less than 12. In fact, it's probably going to be less than 10. And here's why I say that. If we multiply 28 by 10,
Yes.
what do we get?
280?
280. That's already bigger than 265, so it's got to be less than 10. But not too much less than 10 because 280 is pretty close here. So what could we try?
9.
9. And that's the thing with long division, or whatever we want to call it, is that sometimes we just try something and see where it gets us instead of overthinking what it could be. So let's go with 9.
And for the sake of time, that'll come out to be 252.
252. So we'll subtract that. We end up with 13 left. We'll bring this up here. And now we can do 28s into 139. Now remember when we did estimating here?
Yes.
We could probably do the same thing here.
Yes.
Now let's try 30 and maybe 140. How many 30s could fit into 140?
About 5?
We could try 5. That would end up being 150. It might be too big. So if it's too big by just a little bit, we can come down one more.
Yes.
So what could we try instead?
4.
So let's do that. 32. We have 100. Now we're going to have some left over, and that's okay. Ooh, not much. But it's not quite enough to form one whole group. However, we know that there's going to be 27 left of that last group of 28. So we're going to make that a fraction. 94 and 27 28ths. Now, is this close to 100?
Yes.
We should feel pretty good with that then. So, 2,659 divided by 28 is about 100. In fact, it's so close to 100 that it's 94 and 27 28ths.
There you go. Nicely done with that first problem, Isabella. Hey, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. Now, Isabella, you said that you've been a bulldog for 6 years, so you're used to California weather, correct?
Yes.
Does it ever get very cold here?
It'll get cold, but not really freezing.
Not really freezing, right? It's not really cold, right? Well, in the newspaper today, there's an article calling for record low temperatures. So record cold follows early snow. And you may not be able to see. Now, you see the waves right there, Isabella?
Yes.
Okay, and I don't know if you can see, but up on the pier up here, that's ice.
It is.
That's ice. So that means it's what? It's really cold, isn't
Really
it?
cold.
Okay. In fact, if it's going to make ice, what does the temperature need to be? Do you know what it needs to be to freeze?
-30.
It would freeze at negative
it
30.
would freeze,
I don't think
right?
it'll go that far, though, if we get started.
32 degrees is freezing, all right? So that's on the Fahrenheit scale, all right? So here's a little something that was on the internet this morning also. Possible record lows Wednesday morning, over 100 potential records. And you can see a lot of the southeastern United States, even down in the Gulf area, are expecting record lows. Would you like to live there?
Probably not.
Probably not. Not if you're used to California weather and then all of a sudden you have this kind of cold weather coming, right? So here is a thermometer. And can you read what that thermometer says right now, where that mercury is?
20 degrees.
Oh, yeah, that's about 20. Well, it's a
Right,
little
so
higher than 20.
here would be a 20 right here, right?
About 30.
Okay, so we go up. So this would be 32 degrees. Here's your freezing point, right? So you've got 32 degrees right here, and that's 0 degrees Fahrenheit, all right? So that's the freezing point. Now, the reason I bring this up is because it happened today that all of this news came out. But it also has to do with positive and negative numbers. Are you familiar with integers yet?
Yes.
Tell me what integers are.
Integers are positive and negative numbers.
Yeah, they are, and we have them right in front of us now, right? So we have zero, so zero is neither positive or negative, all right? So we have a bunch of negative numbers and positive numbers as well. So if you were working on a number line, you could easily manipulate that, correct?
Yes.
All right. So let's see if these make sense to you. If we had 5 plus 2, we know that that's 7.
Yes.
But if you had -5 plus -2, does that make -7?
Yes.
How do you know?
Because if you're adding a negative and a negative, it'll be a negative.
Right, you get more negative,
More
right? So
negative.
if you're at -5 on the number line and you go back 2 more, you're going to be more negative, right?
Yes.
So that makes sense to you, right?
Yes.
Now let's take a look at the next one, -10 plus 12. Why is it 2 and not -2?
Because you have a positive and negative number. When you add them together, you'll get a positive number because you're subtracting from.
Right, so we want to find the difference of the two numbers.
Yes.
And the difference is 2 and the 12 is larger,
Yes.
right? So that's what you're thinking of right there?
Yes.
So you're pretty comfortable with adding and subtracting integers?
Yes.
All right, let's move on to the next step. What do you think that is?
Multiplying and dividing.
You are a smart young lady, I can tell you that. All right, so 2 times 5 is 10. Now, -2 times -5 is 10. Why is that?
Because when you're timesing by negatives, you'll always end up with a positive.
Always. When both signs are negative, the answer will always be positive, right? Now, over here, we can see that it's negative. Why is it negative over here?
Because one is positive and one is negative.
Right.
When you have those two, you'll get a negative.
And these are just written in a different form, but they're still being divided right here.
Yes.
Okay, so the long division that you were working with was written one way.
Yes.
Okay, and then the way Devin wrote it on the board is written a completely another way. And when you put it in fractional form, that's another way. And you're going to be working with a little bit of that later on. Are you ready for that?
Yes.
All right. But anyway, record low temperatures around the United States. Today's Math in the News, except here in California. We don't deal with any of that,
No.
right?
Take it, New York.
All right. So we do have phone tutors available until 5:30 this afternoon, and we also had an opportunity to visit with the Kern County Farm Bureau and one other farmers. Let's check that out.
Hey, welcome here to Math in the Real World. We are here on a beautiful Kern County morning here in the vineyards, which are a regular site here in Kern County. We want to learn a little bit how these grapes grow. We want to learn a little bit about the math that goes behind making those amazing table grapes that we all enjoy each summer. So we brought in my friend Jeff Rasmussen. Jeff, thanks so much for being with us today.
It's a pleasure to be here.
Tell us a little bit about what you do and how you make these things grow and be so delicious.
Well, I'm happy to be here. I'm real passionate about growing grapes, and so I'm an agronomist, kind of a plant doctor.
Okay.
And my job is to make sure the plants are healthy and the fruit is sweet and crunchy.
Right. So the plants get sick just like we do, and they have conditions, and you are going to go in there and figure out what's going on. Right?
Yes, so I'm a licensed pest control advisor.
Okay.
So I'm licensed through the Department of Pesticide Regulations.
Uh-huh.
And so I write like a doctor prescription.
Okay.
And I have to go out and identify the pest. And then I try to figure out what is the least resistant pesticide, which was medicine for the plant.
Right.
And then I try to figure out what we can do that's least resistant to the diseases and organisms that are beneficial. And then what's obviously safe for human consumption.
Right.
And then we grow premium table grapes.
Wow. And so there's so many different things I'm sure you have to take into account, right? I mean, there's weather conditions and there's soil conditions, and then there's your pests that come in, and you have funguses and all kinds of things to think about. Tell us a little bit about your background. How did you learn to do these things? And there's a degree in this, right?
Yes, there's many degrees you can get.
Okay.
And agronomy is kind of the broad. I got a horticulture degree from Cal Poly.
Okay.
And so I kind of stumbled into this, and it was a great opportunity for me to learn more and dive in deeper. And how do we use the different sciences like entomology that discovers, insects, and then
Right.
plant physiology and how the plant grows and how we grow the vine and produce fruit. And then there's, pathology with all the diseases. So there's many aspects of my job. And so there's many forms you can get into the science about how to become an agronomist.
Yeah, you can be you're like a detective each day when you come out here and take in the hints that you're given, right? The
Yes.
clues that you're given, and you get to solve the mystery.
Exactly, yes.
That must make it exciting and also a little bit challenging, right? Each time, if you come up against something new, or maybe even an old problem that your typical methods aren't working on.
Right, and that's what I love. See, I never go to work. Each day, I'm learning something new, and I'm trying to, like a detective, right? And I'm always trying to figure out, is this a nutrient problem, or is this a disease problem, or an insect problem?
Right.
And I kind of have to predict that, and we've had weather, and so you're always kind of thinking, and that's what I love, is I'm always thinking how to be a partner with Mother Nature and just grow premium table grapes.
Right, and be able to work with all the people who are an integral part of this whole production process, right? I mean, from the beginning all the way to the end, you got to work with all the people that are around you as well.
Exactly. I'm glad you brought that up. So yes, I have one portion of it, and then we have all this labor that's in here, and that we have to use. And in table grapes, there's a lot of labor involved, and that's part of the balance where you use crews to come in, obviously to prune the vines, and then remove leaves so we get more air movement in there, and light, and so you have all of this complex systems going on. And to grow table grapes.
Yeah. Real quick, just before we get into the math part, we'll do it on our next segment, but tell us a little bit about the Farm Bureau, how you're involved, and how we got a hold of you through the Farm Bureau.
Yeah, so thank you. Yes, I'm currently past president of Kern County Farm Bureau.
Okay, right.
And so Kern County Farm Bureau is an organization that's been around for 100 years. And we're here to work with the community and farmers to handle their issues that go on within farming issues that, how do we deal with a pest? And then a lot of it is political power of understanding how we make laws locally and statewide and work federally. So you could work on, locally legalization of cannabis and hemp.
All right.
And then you have issues of water.
Sure, I was going to say, I'm sure there's water issues there too.
Always water,
Yeah.
and immigration and labor. So, and just being in part of the community.
Right. We're so glad that we got a hold of you through the Farm Bureau, and we're going to talk a little bit more specifically about the math that goes into the day-to-day operations out here in the vineyards. Oh, wow, there's so many numbers that are flying around this place to make these amazing grapes, and maybe we'll even get a chance to try some as well. Right now, we'll go back to the studio.
All right, thanks for that. We'll find out a little bit more about the Kern County Farm Bureau from Jeff and Scott in just a little bit. In studio right now, we have 5th grade Isabella from Buena Vista, home of the Bulldogs. Been a Bulldog for a long time.
Yes.
Lifelong.
Long division is going to be even easier for you after today, we hope. All right, let's go to the board and try one more.
Yes.
So we'll just go on to the next one. 9,155 divided by 34.
Okay. So we can estimate, but I think we want to get into this model that we looked at before using the boxes for place value. So let's see if you can set that up the same way. Go ahead and set this up under our long division box model. How would you set that up? So we have our number we're dividing by on the outside, and then we're going to split our original value up by place value. There we go. Okay. Now, what do we do with each of the values in our number here?
We'll put them in a box and then
Let's go ahead and do that. Okay, go ahead and create those boxes so you can start organizing all of these digits. In fact, if you want to, you can even move some of these over so that you have a little bit more space there. Look at that. So let's try that. Let's try giving ourselves a little bit more room in these boxes here. All right? So we have that, and we have our 1, and we have our 9. All right, go ahead and create those boxes. Now, we're going to work one square at a time here with our larger number, but we want to work with the largest place value. So what digit is in the largest place value?
9.
9. So we start off with 34. How many times can we squeeze 34 into 9?
We can't.
We can't, so something's got to go up there. We need a 0. So when we multiply 34 by 0, you have all the time you need. Do that in your head. 34 times 0. 34 times 0. It's only an hour-long show. We got to get this quick. What is it?
0.
0. Let's go ahead and throw that down. When we subtract, we know we're going to get what?
9.
Okay, so what are we going to do with that 9 now?
We're going to take it up to the 1.
Okay, so go ahead and put that 9. So we have now 91. About how many times do you think 34 can get squeezed into 91?
2 times.
Let's try 2. That's a good guess because 34 is close to 35, and we know double of 35 is 70. So 2 might just get us there. So when we do 34 times 2, or 34 plus 34, that's the nice thing about these 2s. We can just add that number to itself. Where does that get us?
68.
Let's go with 68 and subtract. We may want to move that over under so that we can line up the place values because there may be some regrouping necessary. So we start with the 1s. Can't do 1 minus 8, so we're going to have to regroup there. Bring one of our 10s into 10 additional 1s. So now we can do 11 minus 8. And we can do 8 minus 6. Okay, so we have 23. We're going to do something with this 23 as we continue forward.
We're going to take it to the 5.
Let's take it to the 5. So we bring that 23 next to that 5 and the 10's value. We may have to squeeze it in.
Yeah.
So if you need to erase that entire 5 to get our whole value in, that's one of the luxuries of being able to work with this device. So we have 235. So this is going to require a little bit of guessing here, but we can figure out what it's going to be close to. We know that 34 times 10 is going to be 340. We're not quite there, but we're more than halfway there, I would guess. So what do you think would be a reasonable guess?
8.
We could try 8. Let's see what happens here. 235. We want to get less than 235, but not so much less that we can still get more in there. So let's try with 8. 34 times 8, 32. Bring your 3 up here. 24 and 3, that's 27. Ooh, 272. What does that tell us about 8?
It won't work with.
It's too big, so we're going to have to try something smaller. What do you want to try instead of 8?
7.
We could try 7. Now, instead of multiplying by 7 here, we can just take 34 away. We just found times 8. So let's try just taking 34 because that will be times 7. We're going to end up with 38 left over. Now, it's closer to 235 or 238. So,
We're at
a little too much, but that's good information because we know where to go from there. What can we try then? We tried 8, too big. We tried 7, got closer, but still too big. What comes next?
6.
Let's go with 6, okay? So we're going to subtract another 34 here. That's going to give us 204. Now, when we took that away, we're going to do 235 minus 204. Subtract that, we have 31. What do we do with that 31?
We move it over to the next 5.
Let's bring it over to that next 5 in the 1's place, and we end up with 315. Now, remember when we said that 34 times 10 was going to get us to 340?
Yes.
So this looks like it's close to 340, but not quite there. What should we try?
8.
We could try 8. Now, I believe we already figured out 34 times 8. We ended up with 272. So if we do 315 minus 272, it looks like we end up with 43. So we still have room to put one more in there. So what do we know it has to be?
9.
So let's go with 9, okay? Now I'm going to take that 272, and instead of taking one away to try with 7, I'm going to add 34 now. And we're going to get to 306. So when we subtract 306 from 315, we're going to end up with a little bit of a remainder. Now, when we have a remainder, we don't just write R. This represents the part of the last group of 34 that we have left. So how would we represent that?
A fraction.
As a fraction. Go ahead and write that fraction off to the side. 9/34. So let's look at our solution here. I'm going to take that 0 and just pop that out of the way. 269 and 9/34. So 9,155 divided by 34 equals 269 and 9/34. Isabella, wonderful. I feel like you found your home here with this division model. Nicely done.
That is some great work right there. So always, sometimes you can learn a little something new right there, right? Never even thought you were going to be doing long division like that, did you?
No.
Well, for some great work, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. We'll be back with more right after this. Today we're at Kernville Elementary School, home of the Mountaineers, and we're here to All right, here we are once again. We've got some 4th and 5th grade students at Kernville Elementary School. You guys ready for your final activity?
Yep.
How many of you have ever done logic before? You're like, I don't know what you're talking about, right?
Nope.
Okay, well, let's take a look at what we're going to do. All right, so take a look at the card that you have with your partner. Up at the top, so you and I, Bella, are going to work together. All right. So on this one, it says we need 2 white, 2 black, 1 red, and 1 orange. Okay? It gives you clues. What you want to do with your partner is place these markers in the appropriate spots so that it satisfies all of the clues on your card. So you have to think. Now the first one, what does that say, Bella? So read number 1, the whole thing, clue 1.
The white chips are in the same row but do not touch.
So the white chips are in the same row. So take the white ones. Now a row, now you need to know the vocabulary. A row goes across. A column goes up and down. Okay? So let's see. Clue 1. So read it again.
The white chips are in the same row but do not touch.
So are they in the same row? But are they touching? So if they're next to each other, they're touching. So what do you need to do? There you go. All right, you guys get the idea?
Yeah.
So you need to know the difference between a row and a column. Touching doesn't mean they actually have to be like this. Okay, if they're next to each other, that's touching. Okay? So with your partner, go ahead and start working on the clues, and we'll see if you can fill in your card all correct.
The bottom on the right.
Because orange chip is directly across the other orange chip, and
You leave them there?
yellow
All right.
is
Clue number 3.
has to go right here.
But they don't touch. Okay. Clue number 4. You finished?
Yeah.
Did you check it?
We'll double check. Wait.
Double check it one more time. What number do you have?
It's below it. We have number
3? All right, so it should say black, orange, yellow.
Yes.
The second row, red, orange, blue. Try putting a blue there. And then purple, green, white. There you go. Now check all of them to make sure that it satisfies it perfectly.
We finished.
You finished? All right, number 1 should say blue, green, orange. Oh, so put an orange up there and try it again. Yellow, white, black.
Yeah.
Red, red, purple.
Okay. So that's how it was, but then we got.
You had it like that? All right. So let's find out the last group. You guys all finished down there? Almost. Keep going. All right. You should have a row of red, red, red. Blue, yellow, black.
Nope. We're messed up.
All right, so you guys are going to work on yours a little bit more? All right, so we'll let that group keep on going. And you guys have worked figuring out with these logic problems and the clues how to solve a logic problem. And those are the 4th and 5th grade students at Kernville Elementary School. This was made last night specifically for you. And what are you laughing at? You forgot the cheer and the move afterward. What's going on? A big thanks to the staff and especially the students at Kernville Elementary School. We had a great time out there. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. In studio we have Isabella, a 5th grade student from Buena Vista who has been a lifelong bulldog. You looking forward to when you have to go to junior high and high school?
No.
No? That's all right. You still have a year left. But right now we do have another opportunity. Head on out with the Kern County Farm Bureau. Check out with Jeff.
Hey, we're back here, a little math in the real world. You know, as Thomas Jefferson once said, those who labor in the earth are the children of God, if ever he had them. And so I always like being outside. Always love to be outside, to know what's going on around us, but also to know that numbers really are part of nature. And so we're really glad to have Jeff Rasmussen with us here today to show us a little bit about what he does. You know, when we go to the grocery store, Jeff, we see these beautiful grapes, right? They're so beautiful and, of course, awfully tasty. And we don't see always what happens behind the scenes. Now, when you go to the field, you see these grapes, which are wonderful, but you also see some that are not so wonderful. So if you come across a bunch of grapes that looks like maybe some of the ones you brought here for us today, what specific attributes of those bunches of grapes are you looking at in order to diagnose the problems?
Wow, that's a lot. It's great information. So before, like I said earlier, you know, my job is to look at plants and understand a healthy leaf versus a sick leaf.
Okay, so you're looking at the foliage first.
Right, and so, and the plant, right?
Sure.
And so, as us as humans, you know, we wake up and some days we don't feel so good. So sometimes we have a cough or we're sneezing. Yeah. I listen to the plants with my eyes. And so I look for symptoms, right? And it could be nutrients like this one. This is a magnesium deficiency, okay? And see, as it gets worse, as your cough gets worse, it goes to your lungs. And see this margin right here, it's very patterned. So I listen to it, and that's a magnesium deficiency. Okay. So that's gonna affect the chlorophyll. Okay.
And as we can see, as it goes too long, it becomes brown, right?
So it goes from chlorosis to necrosis. Okay. And necrosis is that crunch. Again, these are the symptoms that I'm looking for. Right. And then, you know, I could use different elements in the soil to change the pH of the soil. Okay. If I have a high pH, I can reduce it, and then the mobility of the nutrients become more available. Yeah. Okay. And then when it comes to, that's the nutrient side. Okay. And then we look at plant symptoms. Okay. Obviously, those to the left there are healthy and beautiful. And then you move to the left, we have other issues going on. Now, this disease right here is called powdery mildew. And that spore landed there, and about 5 days it germinated and started recycling again. And if I let this disease go, it goes from one spore to here off the leaf onto the fruit, and it goes from this spore to here to that spore. Okay? What happens is the skin later on, as the grapes get bigger, they start to break down. Okay? And you can see right here this little indentation right here.
Yeah.
When that fruit was smaller, it left an indentation there. Okay? Now the skin's thin and it's growing, all of a sudden it breaks apart. Then you start getting rot complexes, okay? And then I start losing yield to the rot. And then the pickers have to clean all that out.
Right.
And so therefore we have to use what we call the tools of the pesticides.
Right.
Okay?
Right.
And so we have different types of pesticides. Some are fungicides that take care of the fungi. Then over here we have insecticides where we have mealybug. This is called vine mealybug, where you can see the stickiness, and they're really small in there. You really can't see right now, but you can't see it or feel it on the, but they're kind of, you see how my skin pulls apart right there?
Right.
It leaves a residue.
Right.
And that's their waste, and people probably won't like that in the eating that stickiness. So,
Yeah, probably not.
so we have to take care of that. And so my job, I write a legal document, kind of like a prescription.
Right.
Okay. And
Because you can't just have random people out here trying to figure out the problems.
Right.
You have to have some training, and you
Right.
got to make sure you put the right applications. And so you actually have a prescription here.
Right. And
Yeah.
so I have to know the different insecticides and fungicides. Again, I'm trying to find the least resistance that has influence on our environment and to human health.
Right.
And then I have to worry about different insecticides and not using the same class of chemistry. Then I build more problems because now I build a resistant of that pathogen.
Yeah. Yeah. That
So,
makes sense.
so then I have to choose which materials go into this treatment.
And you have all kinds of choices. I mean, there's so many different things you could do. So knowing what each one does and knowing specifically how much of each one to use has got to be unbelievably important.
And not that, is there something I can do physically, right? And so, it's 100 degrees today, and there's chances of rain this weekend.
Oh.
And so, as you can see right here, the whiteness, and soon soon you'll see.
Yeah, let's see.
We're gonna put out a big umbrella, okay? And we'll open this plastic up, and a lot of people will see this, and we'll open this plastic up really
right.
wide.
Yeah, you see those
Okay.
vines where they have all
Yeah.
the plastic over top of them.
So not only do we use chemicals, but we also use other means to prevent rain coming in. And so this is what we'll use. We'll open this up, plastic up, and to protect the grapes, okay? We'll open this all the way across.
Gotcha.
And then that way, when the rain comes down, it won't affect our beautiful crops. And we'll go in a minute to see what we need to protect on this block here.
Right. Oh, so much wonderful information. So when we come back, we want to see a little bit more specifically about the actual grapes that are there on the vine, but also some numbers. We know that there's some numbers about the way you mix things up, all kinds of fun stuff, but we also know there's some numbers back in the studio. We'll get there and come back soon.
All right, numbers all around. Numbers in the field, numbers in the studio, numbers with Isabella. You ready to do some more dividing?
Yes.
This time, instead of the large numbers you were working with, we're going to work with decimals.
Okay.
All right, so head on over to the board. So the first one we've got is 65.6 divided by 8.
So this looks very similar to other problems you may have seen before. So I want to let you determine how you want to set this up and approach this. What strategy towards division do you want to use to start things off?
Probably take away the decimal point.
So if we're going to take away the decimal point, what are we going to do with it later?
Put it back.
Put it back. So you just want to put that decimal somewhere off to the side here, okay? We're just going to keep that over there. So we're going to treat this like 656 divided by 8, okay? So how would you set that up? So we're going back to the long division-ish bracket. Setting up 656 inside and 8 on the outside. Compared to the numbers we've been working on all day with 28s and 34s, 8, I'm happy to work with. I don't know about you.
Yes.
So let's go ahead and play around with 8. Let's divide 656 by 8. Go ahead and kind of think out loud first. Tell us what you're thinking as you look at this.
I'm trying to round the number that we're dividing by just to get it smaller. So what I'm thinking is 6,400.
Would this be 6,400
64.
or 640?
640.
Okay, so
And
if we do that, if we think about this as 640 divided by 8, we know that 8 can go into 64 sometimes, right?
Yes.
So how many times can we fit 8 into 64?
80 times?
Yeah, so if we do 80 times 8, we're going to get 640. So we know we have 80. I'm going to put 80 up here. When we subtract 640, so we found 640 out of the original 656. We have 16 left. So we have to figure out how many more 8s can fit into 16.
2.
That doesn't sound too bad, yeah. So we do 16 divided by 8, and that gives us 2. So we have 80, we have 2, 82. Now, we did something though, right?
Yes.
We needed to bring something back in. We took something out, and you said, everybody heard you. We were on TV, everybody. She said she was going to bring it back. So I want you to go ahead and put that down. I'm going to give you that decimal point back. It's yours. Do what you will with it. Where do you want? You can just use your finger and bring it. You said you were going to take it, so I'm giving it to you. I'm giving you that decimal point back. So what are you going to do with that decimal point? Now that's an interesting choice. Why did you decide to bring that decimal point there?
Because if we were to do the problem with the decimal point, it would be right here.
So when you have a decimal point here, it generally comes right back up above it in our solution.
Yes.
So what this means is that 65 and 6/10 divided by 8 equals 8 and 2/10. Wonderful job.
Nicely done. Now, one of the things that you missed out in class the other day we heard, was fractions.
Yes.
And an introduction to them. So let's go ahead and just work with some vocabulary with a basic fraction. Let's go 3/7.
Okay.
So 3 over 7. Talk about a little bit of vocabulary, and then we'll go from there.
When we talk about 3/7 as a fraction, there's a lot of parts of this that we really want to recognize. We have 3 components here to make up a fraction. Which of these could you name?
The denominator?
So the denominator. Which of these do we identify as a denominator?
The bottom number.
Okay, so 7 is our denominator. Now, what does the denominator generally represent? If we had like a situation where we had 7 of something, let's say days of a week, okay? So what does the 7 represent?
How much of something can fit in?
Yeah, so with a whole set, right?
Yes.
Okay, what's another part of our fraction here?
Numerator?
We have a numerator. Okay, so let's say I talk about days of a week that, let's say I just talk about Friday, Saturday, Sunday. 3 out of the 7 days. What does that 3 represent? What does the numerator represent?
How many days you said?
Yeah, so basically the parts of the set that meet a certain criteria. Some people think of the denominator as the whole, but you can think of it as the entire set. And there's one more part of a fraction that we haven't really talked about yet. What would that be?
The line?
The line. Is there a term for what we call that line? What would you call that line? If we wanted to say something very academic, vocabulary-ish about that line, we could just call it a line? If we were to think like mathematicians, what could we call this line?
Separator?
We could call, ooh, that is very I like that. I'm going to call that the separator. You may hear it referred to as a fraction bar, which doesn't necessarily have the same. I'm going to put both down. The fraction bar or the separator. Now, I want to show you something really interesting about fractions. we talk a lot about the relationship between fractions and division. And you may have seen the symbol for division, which is 2 dots with a line. How is the division symbol similar to a fraction? Just by looking at the 2. What do you notice?
You just replace the numbers with the dots.
Absolutely. When we have these dots, they represent numbers. They could be anything. The reason that this is the division symbol is because it resembles a fraction where we don't know what those numbers are. So that's our clue that there's a relationship between division and fractions. So we know that fractions have parts that represent different values, but we also know that it represents a division expression when we have values put in.
So now what we'd like to do is, now that you've got the basic vocabulary down, and quite nicely done when you already knew that.
Inventing vocabulary,
Devin
huh?
was going to bring that into you right there.
Yeah.
But anyway, let's keep our 3/7, and to that we will add, how many sevenths, Isabella, would you like to add to 3/7?
5/7.
Oh, very good. All right, so we'll do 3/7 plus 5/7.
Now, before we do anything else, we're big on vocabulary and using words to express it. And a big part of words and vocabulary is writing this out. So if it's okay with you, I would like to write this out using words instead of simply using numbers. We use numbers sometimes because it's easier than writing the words out, but here I think it's really important. How would I write this fraction? 3 what?
7ths.
Sevenths. So I want to write that as a word here, right? And to this, we're going to add 5. 5 what?
7ths.
Sevenths, okay? So, if I have 3/7 and I add 5/7, how many sevenths do I have?
7, 8.
And I have 8, right? Whenever I have 3 of something and I add it to 5 of that same type of thing, I have 8. 8/7. Now, how could I write this as a fraction to satisfy this expression? What would my numerator be, and what would my denominator be?
Your numerator would be 8, and then your denominator would be 7.
Now, what am I missing between those two?
The separator?
The separator, the fraction bar. So, I want you to take a look now at the addition of these fractions. I know that a lot of people would end up adding these together and getting 8/14. Why do you think they would get 8/14?
They would add the denominators?
Absolutely. If you have the same denominator, do you add the denominators together?
No.
No, because they're the same unit. Fractions are a representation of a unit, and we always write out the unit and keep the unit consistent and the same. We're just adding the number of those pieces together. So 3/7 plus 5/7 equals 8/7. Very nicely done.
All right, let's move on to the next part. So
Okay.
let's keep our 3/7.
Okay.
So we'll stay with 3/7. And to that, Isabella, we will add, let's say, 4/14.
He sure did it to us, didn't he? If we try to write it out like this, we're going to end up with a problem, aren't we?
Yes.
What do you think the problem is going to be?
You're going to have 2 different denominators.
I have 2 different denominators, which means I have 2 different units, right?
Yes.
Now, let me talk you through a hypothetical. Let's say I have 7 apples and 3 oranges. What do I have?
You have 10 fruits.
I have 10 fruit. You said a really interesting word. You went with fruits. You didn't say I had 7. You didn't say I had 10 apples or 10 oranges. Why did you choose fruits?
They're both different types of fruits.
You found what was the same about those 2 different types, right? They're both types of fruit. So you used the unit that was common between them. So what we need to do with our fractions, before we're able to add them, because we can't right now, they're different units, we need to find a common unit with our fractions, which means we need to find a way to make our fractions equivalent enough that they have the same denominator, the same unit. Is there something we could do with one of these fractions that would allow us to do that?
You can multiply.
When you say multiply, what do you mean?
we can multiply the 7 by 2 to get 14.
So you're saying you want to take 3/7 and create an equivalent fraction in 14ths. So when you multiply 7 by 2, you get 14ths, which means we have to do something up here.
We need to multiply
So what are we going to multiply the 3 by?
2,
And that gets us?
6.
Now I'm going to go ahead and rearrange this over here. We don't have 3/7 anymore. We now have 6/14. Can we add these now?
Yes,
Okay. And we end up with what?
10/14.
10/14. Question, was that the only way we could have done that?
No,
Okay, what else could we have done?
we could have found another multiplication problem.
Okay, explain.
We could have times 14 by 2 and then times 7 by 4.
We could have gone with 28ths as a common denominator. We could have done that as well. Could we have done something with 4/14 while leaving 3/7 alone?
No,
Is it possible, since we can multiply up to find an equivalent, to sometimes divide down if we know that there's a common divisor between our numerator and our denominator? So for example, within 4/14, can I divide that by 2?
yes.
When I divide 4 by 2, and when I divide 14 by 2, we end up with 7. So we can convert 4/14 to 2/7. And when we add those together, we're able to get 5/7. Now, 5/7, and originally we found 10/14. Could you convert 5/7 into 10/14?
Yes.
So this tells us that both of those are equal, which means no matter which way we approach it, we still end up with fractions that have the same value, 5/7 or 10/14.
And that is some excellent work right there. And I'm glad you guys went over that, where you would take and simplify the other fraction. Great work right there. Congratulations, Isabella. You've got yourself a couple of tickets to go see some ice hockey with the Bakersfield Condors. So congratulations on that. Hey, we have one more opportunity. We'll go check and see how the grapes are doing with Scott and Jeff.
Hey, we're back out here in the field, a little math in the real world. Love to be in the vineyards here with my friend Jeff. And of course, the best part about this whole deal is we get to eat grapes while we do this last part, because man, that's the ultimate goal, is to make these grapes nice and healthy and delicious. We really want to talk about some numbers though. So
Okay.
Can you give us some numbers? You find a problem, you got to go and apply some chemicals or some pesticides or some fungicides, something, but you got to make sure you apply it at the right amount, right?
Yeah. So, but Scott, come on.
I got to try these
You gotta.
out, no doubt.
So you notice these. You hear that crunch?
That's one of the best part. I love grapes that are nice and crunchy.
You sure? Try that again.
I better try that.
So the problem is, premium table grapes. It's about chewing good grapes.
Yeah, yeah.
So you get the punch of the calcium, okay, and that sweetness comes behind it.
So
And
the
that's-
calcium is what makes it crunchy.
No. Yep.
Okay.
Builds up the calcium. You'll learn that in biology.
Right.
And then the potassium is the sugar part.
Okay.
So how do I get those balances?
Yeah.
Because what happens is, I get kind of Mother Nature. If I get too much of a good thing, I start fighting. So you got calcium, magnesium are together, but they kind of fight. But their bigger fight is with potassium.
Okay.
So you have kind of like this teeter-totter.
Yeah.
So I have to figure that out. And so we go back to this recommendation, is I got to figure out, I can put on more potassium, but I kind of got to match that with the magnesium and calcium,
Okay.
right? So it's-
just putting one thing on at a time would really disrupt the balance.
that's right.
Yeah.
So, but to get to the good stuff that I love is math,
Right.
because I have all this stuff, and then I have to order this stuff.
Sure.
And you can see there's different packaging of this stuff, and so I may put on 42 ounces of potassium, but I may put on 25 ounces of the calcium here. And then I'll add in a fungicide, right? And that fungicide will come in different packages. Like this one comes in small containers, okay? And this one comes in 1 pound containers. So we have to figure out the math. I know the math that I put on 42 ounces of this and 6.2 ounces of that, and then I have to call someone and say, can you order this material?
Right.
They're okay, but if I just give everyone in ounces, 100 ounces, that can mean different things, right?
Sure. Oh yeah.
Because you have different packages now. Now we get into different packages.
Yeah.
So we can have fun of saying, hey, I need 3.2 ounces of Bathroid. That's a fluid, okay? And I may put on Rowley that comes in a wettable, soluble form, okay? I may put 5 ounces of that, but the package comes in 4-ounce containers.
Right.
So I have to make sure that I don't give them a weird package number to put in the tank, because then they can't mix it, right?
Sure.
So
yeah.
then we have, different measuring containers to do all that.
Yeah, man, there's so much going on here. This is kind of a neat deal. And you have to have that, like we talked about, you have to have that balance of different things. So you're putting more than one thing in a tank when you're going to go spray to make sure that balance is happening, right?
Right. And then I don't want to damage the grapes that sometimes you have incompatibility problems.
Right.
Where you have to figure those players that don't get along.
Yeah, what a real life scenario. What a real life problem that you have to solve here, because there's so many aspects to it, just like almost everything run up into real life. If you were going to suggest to a student who is really interested in agriculture, but also interested in math, maybe even being a plant doctor, what do they need to do? How do they get involved in something like this?
The first thing you need to do is know what you love learning about.
Okay.
Don't worry about the specifics.
Right.
If you love growing plants, go learn about growing plants. You're not going to know for years to come what you really wanted to be focused in on.
Right.
I've learned a lot of things over the years of my life, but mostly what I love is to learn about plants and how to grow good fruit and vegetables.
Right.
That's what I love learning about. Right. And so you put all this in, and each day I keep on learning more and more about what I do.
Yeah. And you learn from the people around you, and you learn from the things that you're gathering from the vines, right? And you learn from maybe even some informational things that you read about. Do you have to do some constant education for yourself?
constantly learning. I still go back and I still have some of the college books that I learned.
Yeah.
And it's still like, oh, that's what that means. You still get it, and we all learn different ways. Yeah. And some people learn it right away. And you start putting knowledge, and that's where knowledge comes in, of putting those things in practical use.
Yeah, and you're a hands-on guy, I know. You like to get out here, get the hands a little dirty, be able to learn all about this stuff. Gosh, we're so appreciative of you spending some time with us today. I know that I learned a lot, and I know there's a lot more that goes behind those nice, crunchy, sweet grapes than just getting them at the grocery store. There's a whole lot of work that goes on out here. I'm so glad you talked about the balance. Gosh, there's so much more to learn. We'll have to come back here again soon, if nothing else, just so I can get some more grapes. That worked out pretty well, too. But right now, I know we need to go back to the studio.
All right, thanks for that, Scott. Thank you once again to the Kern County Farm Bureau and learning a little bit about doctoring the plants out there in the fields. 636-4357 is that phone number. Phone tutors are usually available until 5:30 most Tuesdays and Wednesdays. We would like to say thank you to Isabella, 5th grade student from Buena Vista, for coming in this afternoon. Did you learn a little bit of math today?
Yes.
Some new methods and things like that? More importantly, did you have fun today?
Yes.
That's the key right there. And don't forget, tell your principal more trash cans at your school, right? Okay. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.